title of the project was Linker. So with a person in computer science, so Mauricio Alvarez. He is a senior lecturer and he's amazing in machine learning kind of thing. So what we wanted to do is to try and bring that together into the cancer science to get the best methodology to be able to follow anatomical changes in kids. Let's apply for this, because then we can get methods from machine learning, we can get part of the knowledge that we have about the brain development and stuff in cancer, but let's also include this Colombian party and then be able to see whether we can create this methodology that will be then applicable to these two different, what they call catastrophic events. So it's when the baby is born with asphyxia, brain injury. That simply means that the kid is going to have very difficult growing up.
So the discipline hopping that I was doing too, because we've been working on projects around trying to understand the late effects of radiotherapy in children with cancer, and we found that there was a lot of longitudinal data that we weren't really making the most of. So we really wanted to have a way that we can harness that data that's not really that wasn't really being used in our projects at the moment.
Part of the things we included in the grant was going back to Colombia and to disseminate the work, the methodology, but also to try and engage with the parents of these kids, of the babies, to try and figure out what exactly they think we should prioritize when we are doing the research. Another parent that is going through this nightmare in the future will have better tools to be able to know what to do and what to do.
I think it helped potentially identify some things we need to consider in the next grant. So because it was only a pump priming fund, we managed to collect some data and really start to test some methods on it.
So we are also writing another grant with Mauricio here. So that will be more into the blood cancer, also with perinatal asphyxia. And that is one of the things we also figure out when we do this pump priming, is that we needed to scale the methodology a lot more. We have an idea of how to do it. We have the methodology, and that's I think when the project became truly interdisciplinary, because then we could talk and then Mauricio could talk and we were finally talking the same language. And of course, this is the problem. This is how we can solve it. So we are now writing down a very exciting proposal for EPSRC. And then we will see it. Global impact.
And I think the thing that surprised me was even when it's just technical researchers working together. I'm a physicist, Eliana's a computer scientist, Mauricio is also a computer scientist, but the
electronic science,
we could be Mauricio also works in computer science, and then with that sort of connection together, we're still speaking quite different languages. So we really come at something with a clinical problem first, and want to solve a problem for the patients, whereas Mauricio was very much interested in what was the technical challenge.
I think at the beginning we had a very good idea. We wrote it down. We had the plans, and then when we were implementing the project is when we started realizing that there were many assumptions we were taking from the two sides. Oh, okay, no, that is not so. All this kind of, and then we started communicating and really making a bridge, and that's what I said. I think maybe. You could even think about the project. We started as a multidisciplinary project, so these people from different disciplines working together, and we became an interdisciplinary project at the end because we finally kind of understand each other, we kind of really put the expertise together in synergy, in one.